Hello, this is Dooyoung Kim, and I'm currently attending the PhD program at KAIST UVR Lab. Our research topic is adjusting relative translation gains according to space size in redirected walking for mixed reality mutual space generation. In this study, we propose the concept of relative translation gains, a novel redirected walking method to create an optimized mutual movable space between the AR host reference space and VR client's remote space. Asymmetric remote collaboration based on AR, VR, HMD draws attention due to the increasing demand for on-tech meetings with co-presence. And for this, it is necessary to create a mutual space based on the host reference space while understanding the client's heterogeneous remote spaces. For this, our research came up with how we can modify the VR client's original movable space for merging this to the mutual space more adaptively. We focused on applying translation gain in redirected walking, which has the effect of adjusting lengths without coordinate distortion. By applying previous study results, we can increase or decrease the VR client space while the space aspect is fixed as the original one. One step further, we wonder it would be better when we can modify only one axis like this, or increase or decrease the width and depth by different ratios for a more mutual space adaptive transformation. And this concept is called relative translation gains. Relative translation gains refer to a pair of translation gains consisting of two different translation gains applied to each axis of the floor. In order to apply relative translation gains, it is necessary to estimate the unnoticeable threshold range to what extent this 2D translation ratio alpha t. Before we estimate this threshold range, we try to figure out the major factor which might influence this range. The proposed relative translation gains are to match the VR client's remote space to the mutual space. The mutual space to which clients access may be a large conference hall as shown in this picture. In some cases, clients might be teleported to a smaller meeting room like this. We also find some research that users' length perception in VR differ according to the size of the VR space. So we set our research question as, how do relative translation gain thresholds differ in relatively larger and smaller reference space? In order to reflect features of the AR host reference space in generating the mutual space, we use two different sizes of VR conference rooms as the reference space, where the larger conference room is 4 times bigger than the smaller one. We recruited 20 participants and used the pseudo 2AFC method for estimating the threshold. We designed 5 paths for participants to experience various perceived speed from given relative translation gain conditions, and each participant experienced both larger and smaller conditions. Results show that the probabilities of larger responses to all relative translation gains in the larger VR conference room were significantly lower than the smaller one. The left figure shows the result of feeding the participants' responses to the psychometric function. The threshold range estimated by applying the 25%, 75% criterion used in the previous study is shown in this right figure. In a larger conference room, when one axis perceived speed is the same as the actual walking speed, the other axis perceived speed can be 15% slower or 29% faster than the actual speed. In the case of smaller conference room, the other axis perceived speed can be 32% slower or 16% faster than the actual speed. And this indicates that for remote clients connected to the larger reference space, relative translation gains can be increased more to utilize a VR space bigger than their real space. Reversely, it can be decreased more for a smaller reference space than a larger one. Using relative translation gains as a space modification term, we can generate more wide and optimized visual space for MR remote collaboration compared to the one-to-one scale intersection method. We discuss our result induced by the difference in the horizon's location in a VR environment according to its space size. When the angle of declination, theta, decreases, perceived distance in VR is biased to be larger, which aligns with our results. Based on these insights, we will estimate a more precise threshold range according to the visual space configuration, such as more diverse size conditions categorized by the angle of declination and existence of visual objects, etc. In addition, the effect of relative translation gains on VR sickness was not clearly analyzed in this study. Our further experiment will reveal the relationship between relative translation gains and VR sickness more accurately. And this is all of my presentation, and thank you for your attention.